Welcome to a new session of the Polkadot Deep Dives. Today we will talk about Parachain templates. There will be Abhishek and myself presenting. Here's the agenda. We will introduce you to two new Parachain templates as alternative to the well-known substrate Parachain template. So we'll explain you what's the rationale for having two new templates. What are the features that are integrated in them, how to use them. This is the agenda overall. Let's start first with the well-known substrate Parachain template. So today, when the builders team wants to create a new project, a new Parachain, they will typically go to the substrate developer hub, and they will fork the substrate Parachain template. And that template is a great starting point for any project. It's originally a fork itself of the substrate node template, and it's been modified to integrate all the modules from Cumulus so that this chain can be registered and used as either a parathread or a parachain on the Polkadot network or Kusama network. So it is, in general, as I said, a very good starting point for most projects, but of course, it's very generic and it's kind of bare bones. So it only has like the minimal functionalities to function as a parachain in its runtime. And we thought at Parity in the delivery services team that a lot of the projects in the ecosystem could benefit from having some templates that would be a bit more let's say fully featured. So that is why we decided to build additional templates to the base one to help them accelerate their development and the time to market of their product. So the two templates that we share today basically provide a bit more meat, let's say, in the runtime, a bit more functionalities, a bit more capabilities. And they benefit from the experience that we got in the delivery services team of working on various projects, internal ones, external ones. We put all that knowledge, all those best practices in those templates. And additionally, these will be maintained and kept up to date by the same team. And they will be kept up to date with the latest Polkadot and Frontier releases. So the first template that we share with you today is what we call the extended Parachain template, or in short, EPT. It's a ready for hacking Parachain template. It starts from the well-known Parachain template, but we have added the assets palette because this is obviously a very common requirement for Parachain to be able to handle different types of fungible assets. We also integrated a lightweight governance system using the collective palette from Frame and a new palette that we will dive into a little bit later, as well as a bunch of other features that we thought should be in pretty much all the runtime. So you can find this new template on GitHub, on the Parity Tech organization, and it's called Extended Parachain Templates. The other new Parachain templates that we are sharing is one that integrates the Frontier project, which means that it makes it EVM compatible. So it is a Parachain that is from the get-go Ethereum compatible, so you can deploy Solidity contracts on it. And you can also create assets. So we've integrated the assets palette. We've integrated the same lightweight governance system, as well as other typical EVM functionalities like precompiles. All that is integrated and ready to use. And you can find it on GitHub at the following address, Frontier Parachain template on the Parity Tech org. So going into a bit more details into those templates, what do they integrate? The extended Parachain template, as I said, is basically based on the standard Parachain templates that we all know. It integrates the assets palette for creating, minting, and transferring arbitrary fungible assets. We also integrated the utility palette, which we think is always very useful for batching transactions. I mentioned a lightweight governance system. So this is based on the collective palette from Frame that we use to create a kind of simple console that has the power to make decisions over the chain's evolution. And we also have built a custom palette called the Motion palette that Abhishek will dive into a bit later when he will do the code walkthrough. This is a palette that allows you to, well, technically wrap the constant calls so that they provide a root origin, which basically kind of links the collective palette to the pseudo palette, if you wish. Then we are also still working on providing built-in support in the runtime of this template for different environments, different, let's say, network like DevNet, mainnet. This is typical case that we have for all networks. So we want to support that built in the template. And this is not the case in the standard template. So typically teams would have to build that themselves. And this is such a common requirement that we want to put it in that template as well. The Frontier Parachain template, FPT for short, is also based on the well-known Parachain template. Also comes with the assets palette, the console, the motion palette, and obviously an integration of the Frontier project. So this is actually a template that we didn't have up to now. We have the Parachain template, as I mentioned before, and Frontier has a node template, a Frontier node template, but that is not Parachain compatible. So it does not integrate all the Cumulus SDK. So what we've done here is take the base Parachain template, take the Frontier node, and we've integrated the two. So now we have a ready-to-use EVM-compatible Parachain template. It will also support dual runtime environments. Currently, we are upgrading it to version 0940 of the Polkadot releases. So it's a little bit lagging behind the EPT, which is already at 0942. But this is also because Frontier is usually at a prior version compared to the latest Polkadot release. So both those templates are available today. You can go to the URLs I gave previously and directly start a project by forking them. And Abhishek will basically show you how to get started with these templates, and then we'll dive into a bit more details in some parts of the code that are interesting. I mentioned the motion palette that we created specifically for those templates, and there's also some very interesting specific code in the Frontier Parachain template. So I will now give the floor to Abhishek for the other very interesting part of this talk.
All right. Hey guys, I'm Abhishek, and I'm the person who has been mainly working along with Steve and others for these templates. And yeah, we'd like to first show you palette motion that Steve mentioned earlier. So it's a pretty simple palette in that I've added a description here. So it says frame palette to wrap council calls providing root origin. So what does that mean? That basically means this palette provides you a way, provides council a way to dispatch calls using the root origin. And yeah, that's it. Let's look at the code a bit. So I'm actually frozen on my stream. So can someone? Okay, it's good. Great. I'll not look at the stream anymore because it's freezing there. Anyways, okay. So you can see here we have three types for palette motion. We have simple, majority, origin. These are all council. These are all council proportions, I should say. So I'll show you the runtime configuration in a bit, but yeah, let's just walk through the code basically. So we provide you with three dispatchables, and they all do the same thing. They check if the correct the correct council was selected, the correct origin was selected, whether it was a simple majority or whether it was a super majority, which is more than 66%. A simple majority is more than 50%, and a unanimous means it's 100%. So 100% of the council agrees, and we basically dispatch the call, and using this via this do dispatch method right here, we emit the event and we say, okay, there is no fees for it, so pays no. And but we do calculate the weight, so we do calculate the inner calls weight, and we return the dispatch class. So and the rest of the calls, they do the same thing, they differ only on the event that's being emitted. And if we quickly jump to the runtime, so here you can see that simple majority is ensure proportion more than for council half. So you can read this as 1 over 2, this is 2 over 3, and this is 1 over 1. So yeah, that's for palette motion. And rest, I think, yeah, oops, why is my screen freezing? uh, I don't know why. Anyways, let's jump to the runtime code quickly. Oh, this is frontier. Okay, that's right. So yeah, this is the correct one. So lib.rs, and we'll go to construct runtime. And right here you can see the stuff that we have added. We have basically added things that we thought are useful. So utility for batching calls, assets, because like most Parachain projects are using assets, and uh, what else? Motion and council, because motion depends on council. And basically that's it. It's identical in XCM configuration and the node structure to the Cumulus Parachain template. But yeah, so we'll quickly just deploy it via ZombieNet. Um, I'll show you the file. So we are just deploying two valid relay chain nodes and one parachain node. Just having a drink of water. So let's go ahead and launch this one. ZombieNet spawn key. It works exactly like the only difference you will see on EPT right now if you visit is that it's on 942, and it's exactly the same as the Cumulus Parachain template except for these additional palettes. Once we have a PR for separating or introducing the runtime into DevNet and mainnet, so there will be two runtimes, then the directory structure will get a bit more uh, not so simple. So yeah, that's the main, I guess, difference from the Cumulus Parachain template once that PR gets merged. So let's bring up Polkadot.js, and yeah, you can see it has launched. And extrinsics, it's basically the stuff you'd expect, so it's working properly. And now let's go over to the more interesting part, the frontier parachain template, which is new basically. So you have the frontier template, which lives on the frontier repo. It's the standalone frontier, standalone substrate node template that's integrated with frontier. And we saw that there was no parachain template that includes frontier for you, so we saw that there was a need for that, and that's why we went ahead and made the FPT project, or the Frontier Parachain project. And basically this is the frontier template in with Cumulus. So you will see that it has palette EVM here, palette Ethereum. So these two palettes are the main ingredients that make this frontier based chain. And there's quite some configuration right here. So I will not be going through all of this, because this can be, like, for example, if I just take hash address mapping, which is which is a deeply frontier related topic, which says that okay, in EVM you have H160s, which are 20 byte addresses, but Substrate natively uses 32 byte addresses. So how do you map between them? So this is handled by something called hash address mapping. And due to this mapping, even the block structures are mapped. So there are basically two chains. So the Substrate chain wraps around the Ethereum chain, and so you need a mapping between them. And that's basically the idea for Frontier. I don't want to make this a Frontier talk, so we'll just stick to what we have added about added to the Cumulus Parachain template that's Frontier related. So I'll just go to the construct runtime here. And it's the same thing as the EPT. So you'll find assets here, you'll find utility here, you'll find motion, council, but you'll also find these guys here. So these guys come from the Frontier template itself. And yeah, so let me just briefly explain what they are doing. So uh, pallet EVM, this guy right here, this is the EVM machine, EVM, the Ethereum virtual machine. So that's included in your runtime, and you can think about it like, okay, this is the main Ethereum part, but Pallet Ethereum is the actual interface between Substrate calls and your EVM calls. So this one is basically doing a sort of a transaction conversion where it takes Ethereum style transactions and submits it to the EVM. Then you have EVM chain ID that you can choose not to have this, but we have this. Basically, it defines what chain ID the EVM machine will have on Genesis. And dynamic fee and base fee are fee related. These are like base fee is compulsory, dynamic fee is optional. And hotfix sufficiency is something that will walk through your addresses. So let's say, um, how do I say it? There is this concept of sufficiency, consumers, and providers. And if you don't have a sufficient ref count, um, your storage will basically be null and void. So this palette takes care of that. So yeah, let's go ahead and launch this one. Start network. The start network does the same thing as the command I showed you earlier. That's ZombieNet, and we'll deploy a few contracts using Hardhat and using Web3.js to showcase you that it's fully Ethereum compatible. Again, Frontier is a huge topic, and I want to keep this talk about the Parachain template. So we'll just show you like what you can do with it out of the box. So I believe it's running right now, and quickly find this one. Yeah, and now let's connect MetaMask with it. So I'll expand view. Where is this? Expand view right here, so we can have a better look. And now, the way you get connect MetaMask to this one is through defining. I'll go through the process again. So we say add network, and over in the networks tab, we say add a network. Oops. We give it a name. So why can't I edit this? Aha. So frontier chain network, and we'll give it the that's the WebSocket port, and the chain ID is 1000. And if you type this and you get no errors, that means that you have a successful connection. If I put a wrong number here, let's say 1008, it immediately complains that the RPC URL that you have entered returned a different chain ID. So that way we know that we already have a good connection. Currency symbol, um, let's call it ETH. Save it. So switch to yes, please. And now you can see we are on the Frontier Parachain network. So this dev guy, this is from a contract that I was playing around earlier. So we'll see how it goes. So all right, account three. This person has a lot of ETH, and you can see why if I show you the chain spec that we start with. So chain spec. Oh, by the way, when you check out these templates, you'll notice that we have added some starting Genesis configuration for you, so that new builders have a way to basically they have some kind of structure, like they can maybe change this to asset one and play around with stuff. So I feel that it's very important for new builders, new substrate people to really see how things are done. And yeah, that's the whole point of chain spec. So we go to EVM, and here you can see we have this account with its private key embedded here so that you can play around with it as well. And it has a lot of tokens, so we add that somewhere. I actually don't know where we add it, but we make sure that that has a lot of balance. So yeah, let's go ahead and transfer some. Remember, this is native token right now. So transfer between accounts. Let's give Alice some thousand maybe. Are we producing blocks here? We are. This is a problem that I've sometimes encountered with MetaMask. It has to do with not resetting it properly. So let me see if I can reset this one real quick. Clear. Yeah, this was generally the problem that you might have with MetaMask. So let's say you start a chain and you stop it, and then you will see that okay, transactions are not going through. What's the matter? The matter is with MetaMask that keeps account of your account nonces, and that can interfere with it working properly. So now that we have cleared it, let's try it one more time. I'll refresh this page and I'll send a few tokens again. 55555. Yep, we did see a balance transfer right here. So Ethereum did execute from our account with lots of our billionaire account to Alice's account. And Alice, if everything has gone right, should see that balance come in. But again, I don't know why Meta. Yeah, it's showing it. So yeah, that real bit that you need to keep in mind. Always clear activity, tab activity to make sure that MetaMask stuff is not getting in the way. Now, the second thing that I'd like to show you is a hard hat deployment. So here we have from the hard hat website a simple uh, repository where I have configured the hard hat user config to call into Frontier at this URL and with our same private key. So we'll try to deploy the lock smart contract that you'll find on this website right here. So I'll just paste it real quick. This one. Anyways, let's go and deploy it. npm run deploy. Oops. Hmm. Let me run it like this. Okay, I'm in the wrong directory. My bad. As you can see, it was deployed at this address, and we'll quickly verify that one. Uh, right here. So yeah, some balance transfer was done to deploy the contract, and I believe you can check this via chain state. Like right off the top of my head, I don't recall where exactly, but it should be somewhere. If I get this guy right here, let's just check it if it goes through. And yeah, count storage is empty. Uh, where is? Yeah, this is the. Oops. I think this is trying to show me that there is some address, there is some contract deployed here, but I'm not entirely sure. So maybe if we can figure this one out, we'll put it in the video later. So, anyways, that was it with Hardhat. Now let's try to deploy one with Web3.js. All right, where is Web3.js? So, yeah, and this is the file. So I'll quickly show you the main function right here. Yeah. So we make a Web3 provider using our WebSockets link. We add our ERC20 bytecode using this mytoken.json, which is what we compile our our Solidity contract into this JSON file using Truffle, and we just go ahead and run this one. So let's see now. I'll go to the correct directory. Contract ERC20. JS and create ERC. So it will send that transaction. This contract, it's also on the FPT repo, so you can have a deeper look at it. But basically, what it does is it deploys this contract, which is quite a simple contract. Let me show you real quick the contract right here. So as you can see, it's just a simple ERC20 that mints a lot of tokens into the deployer's account, and then it will try to send some tokens. So it tries to send some tokens from Alice to Bob, and you can see the transfer was executed. We'll cross check with our Polkadot.js. Yep, there was a balance transfer right here. And these keys right here, so we don't have the private keys for this one due to the hash address mapping thing that I mentioned earlier. So basically, to go from account ID to 32 to account ID 20 or vice versa, you basically add or remove some bytes and you do a hashing. So there's no way you can get the private keys for them. And that's why I can't really show you that Bob did receive these accounts, but you can see that Polkadot.js does report that there was a balance transfer executed. And I believe that does it for our demo. So I'll urge you all to just go ahead and play around with these contracts, provide us some feedback, how we can improve this. And yeah,
So I was
hello.
saying that we could also have shown that once you have deployed the ERC20 contract, then you can add it to MetaMask and directly interact with it from MetaMask and perform transfer of tokens between different accounts. Now, what we want to share also is like those templates, they are still very early on in their development, but we are already looking at the next iterations and the future evolutions. So as we said, we want to provide built-in support for different environment, different networks. This is already being implemented in the extended Parachain template. It will be added to the FPT as well. Obviously, XCM is a very big topic, so we want to provide some XCM related improvements, optimizations within the runtimes on both templates. We also have some ready pre-configured continuous integration GitHub actions to check the code, run the test, verify that everything is compiling correctly before you merge code into the main branch. On the FPT front, as Abhishek already has alluded to it a little bit, we want to look at this hybrid model that we have by default when we integrate Frontier, where you have account at the substrate runtime level and then other types of account at the Ethereum layer. That is one approach. Another approach is to have what we call a unified account model. This is something, for example, that Moonbeam has implemented. So we also maybe want to have some options there so that when you fork the FPT template, you can choose which way you want to go. And obviously, there's many more other ideas that we have, but we also want to hear from you. We want to know if you have some ideas how to improve those templates to make them even more valuable, even more useful from the community. The main idea being that when you start from those templates, you already have like a kind of fast track and on the right track to build your project on. And you have more than the, let's say, the base template that most projects start from. So we want to hear from you. Don't hesitate to create issue on those repos or to submit PRs. And even if you have ideas for other template, maybe there could be some others that we haven't thought about yet. We also want to know about it. So yeah, that's about it basically for those new templates. Well, you know what to do. Go head to the templates repositories, fork them, create some issues, submit some PRs, and we'll be super happy to see these templates evolve and make them even better for you to use and base your project on. Thanks a lot.